Hello there, and welcome to Sleep Science Daily. I'm so glad you found your way here tonight. Maybe you've had a long day, or maybe you're just the kind of person who finds it easier to drift off when your mind has somewhere vast and quiet to wander. Either way, tonight is for you. Tonight, we're not visiting one place. We're not going to a single planet, or a single star, or a single corner of space. We're going to all of it, the whole thing. 2 trillion galaxies, 300 billion trillion stars. Distances so large the numbers stop meaning anything. Forces we can measure but cannot explain. Structures so ancient they began forming before the Earth existed. Tonight is about the universe. And somewhere inside all of that, inside everything that has ever existed or ever will exist, you are here, in this room, in this body, made of atoms that have been part of stars and oceans and living things across billions of years of cosmic history, lying still, breathing, about to sleep. If these quiet journeys give your mind somewhere beautiful to rest, consider subscribing to Sleep Science Daily, one sleepy soul at a time. Let your body grow heavy. Let your breathing slow. Let's begin. The universe is not the night sky. When most people picture the universe, they picture stars, scattered points of light on a dark background, familiar and beautiful and vast. But those stars, every single one visible to the naked eye on the clearest night, are all in our own galaxy, our immediate neighborhood. A small, local sample of one of 2 trillion galaxies. The night sky you have looked up at your entire life is the universe seen through a keyhole. The universe is everything that exists, not everything on Earth. Not everything in the solar system. Everything. Every atom that has ever been part of anything. Every photon crossing space right now. Every living thing on every world that has ever had living things. Every moment that has ever happened. All of it together. And you are not observing it from the outside. You are inside it. Made of it. The atoms in your body are part of the universe they have always been, and they always will be, long after the specific arrangement that is you has dissolved back into the world. You are not a passenger in the universe. You are one of the things the universe is made of. There are 2 trillion galaxies in the observable universe, not 2 trillion stars. 2 trillion entire galaxies, each one containing hundreds of billions of stars. Each star potentially surrounded by planets. Each planet with its own history, its own silence, its own long dark nights. There is no way to hold this number. It is too large for any image the mind can form. So instead of trying to picture it, just let it rest there, somewhere beneath thought. The way certain things settle in you late at night when thinking slows and something quieter takes its place. 2 trillion galaxies. And in one of them, on one of its 400 billion stars, on one small rocky planet, you are here, breathing slowly, about to sleep. The universe has no center. Every point in space is, in a sense, equally the center. From wherever you stand on Earth, on a planet in a distant galaxy, anywhere at all, other galaxies are moving away from you in every direction. You appear to be at the center of everything, but so does every other observer, everywhere. There is no special place, no location more central than any other. The universe does not have a middle. It has no heart. Just an endless arrangement of matter and space, every part of it equally real, equally present, equally the center of its own small view of everything. You are at the center of the universe tonight, and so is every other living thing that exists. The universe has no edge. There is no wall, no boundary, no place where space simply stops. The universe either continues forever, space going on without end in every direction, or it curves back on itself, so gradually that traveling far enough in one direction would eventually bring you back to where you started. Either way, there is no edge to find. No place where you could arrive and say, "Here, this is where everything ends." It does not end. It simply continues, in ways that depend on the shape of space itself, something we are still learning to measure. The universe is expanding right now. As you lie still, as your breathing slows, as the day releases its hold on you, the universe is growing. Not at its edges, because it has no edges. Everywhere. The space between distant galaxies is stretching, every galaxy moving away from every other, not because anything is flying through space, but because space itself is becoming larger. It has been doing this since the beginning. It has never stopped. The universe you are resting in tonight is slightly larger than the universe of yesterday, and tomorrow it will be larger still. It does not rush, it does not hurry. It simply expands steadily, in every direction, carrying everything with it. The universe does not expand into anything. There is nothing outside it. No larger space it is moving through. No room it is filling up. Space is growing, not moving through something else, not pushing against something else. The question of what is outside the universe has no answer. Not because we have not found it yet, but because outside requires a space to be outside of, and the universe is all the space there is. Some things are easier to rest in than to understand. This is one of them. Most of the universe is empty. Not empty the way a quiet room is empty. The space between galaxies has almost nothing in it. A few atoms per cubic meter, a temperature barely above absolute zero, no light except the ancient cooled glow of the Big Bang, still drifting through everything like the faintest memory of heat. Almost all of the universe by volume is this: cold, dark, still. The galaxies and stars and planets and everything alive on them are a thin scattering of warmth in an overwhelming ocean of quiet. And somehow, in that thin scattering on one small world, in one ordinary galaxy, something warm enough to feel wonder found a way to exist. The stars you see on a clear night are all in our own galaxy. Every one of them, the brightest, the faintest, the ones that form the shapes we have given names to across thousands of years of human skywatching. All of them neighbors, by the standards of the universe. All of them within a few thousand light years. All of them in the Milky Way. The other 2 trillion galaxies are invisible to the naked eye. They are there out beyond the reach of unaided human vision, spread across the dark in every direction. But you cannot see them without help. What you can see on the clearest night is a small, warm neighborhood. The rest of the universe watches from a distance too great for light to carry across to you without instruments to receive it. You have been part of the universe for nearly 14 billion years. Not as you, not as this body, this mind, this particular arrangement of atoms in a particular room on a particular night, but the matter you are made of has been here since nearly the beginning. It passed through the Big Bang. It drifted through the early universe as hydrogen. It gathered into stars. It burned. It exploded. It drifted again. It gathered again. It became the solar system and the Earth and the oceans and the long chemistry of life. And eventually, after 14 billion years of traveling through the universe, in different forms, it became you, lying here, breathing slowly. Part of something so large, it has no edge and no center. Something so old, it makes the whole of human history feel like a single quiet evening. The universe has been building toward this moment for a very long time. The nearest star beyond our sun is 4.24 light-years away. 4 light-years. Light, traveling at the fastest speed anything in the universe can move, takes 4 years and 3 months to cross that distance. If you could travel at the speed of our fastest spacecraft, the fastest thing humanity has ever launched, the journey would take about 78,000 years. 78,000 years to reach the nearest star, the closest one. Space is not mostly stars. Space is mostly space. The Milky Way is 100,000 light-years across. Light, crossing it from one end to the other, began its journey before modern humans existed, before agriculture, before language as we know it, before anything recognizable as civilization. That light has been traveling at the maximum speed the universe allows for the entire span of human history, and it still has not finished crossing our own galaxy. We have never left the Milky Way. No probe, no signal, nothing we have ever made has come close. We have barely left our own solar system. The galaxy, our home galaxy, the one we live in, remains almost entirely unexplored, vast beyond any practical meaning of the word. The nearest large galaxy is 2.5 million light-years away. The Andromeda Galaxy, visible as a faint smudge on the darkest nights, is 2.5 million light-years from Earth. The light entering your eyes when you look at it left Andromeda 2.5 million years ago. When that light began its journey, our ancestors were not yet fully human. Stone tools had barely been invented. The planet was in an ice age. That ancient light has been crossing the universe ever since. And it arrives tonight, at your eyes, in this moment, on this particular night, as a soft, pale smudge in the darkness. The universe delivers old messages. And sometimes, if you are patient and the sky is clear, you can receive them with nothing but your eyes. The most distant galaxies we can observe are over 13 billion light-years away. When we look at them, we are seeing the universe as it was when it was young, before the Milky Way had taken its shape, before the Sun existed, before the Earth. We are not seeing those galaxies as they are now. We are seeing them as they were 13 billion years ago, when their light first began the journey that ends tonight in our telescopes. Some of those galaxies may no longer exist. They may have merged, changed, transformed into something unrecognizable. But their ancient light is still arriving, still completing a journey that began before our solar system formed. Every telescope is a time machine. Every distant galaxy is a message from a universe that no longer looks the way it did when the message was sent. Some regions of the universe are moving away from us faster than light. This does not break the laws of physics. Nothing is moving through space faster than light. But the space between us and those regions is expanding so rapidly that the distance grows faster than light can cross it. Their light will never reach us. Not because it isn't trying, it is, traveling at the maximum speed the universe allows. But the ground is moving faster than it can run. Those galaxies are real. They exist right now. They may contain stars, planets, living things, but they are beyond any horizon we will ever be able to reach. No message we could send would ever arrive. No signal they could send will ever find us. The universe contains more than we can ever know, and that portion is growing. The observable universe is like a bubble around you. Not because you are special. Every observer in the universe has their own bubble of visibility, limited by the same physics. The bubble is centered on you, simply because you are the one doing the observing. Step 1 light year in any direction, and your bubble shifts slightly. Inside this bubble, this sphere of space, whose light has had time to reach you, there are roughly 2 trillion galaxies. Everything outside the bubble may be just as populated, just as complex, just as full of stars and planets and whatever else the universe makes. You are surrounded, in every direction, by more universe than you will ever be able to see. And the universe surrounding your bubble is surrounded by more universe still, and so on, perhaps forever. The universe looks the same in every direction. This is one of the strangest and most important things about it. Point a telescope at any patch of sky, north, south, east, west, up, down, and you find roughly the same density of galaxies, the same large-scale structure, the same background glow of ancient light. The universe does not have a special direction. It does not look different one way than another. It is, on the largest scales, astonishingly uniform, the same everywhere. A cosmos without preference, without direction, without any axis that matters more than any other. The universe does not care which way is up. It simply is in every direction, equally, without distinction. The universe is almost unimaginably old and almost unimaginably young. 13.8 billion years sounds ancient, and by human standards, it is. Civilizations rise and fall in thousands of years. Human lifetimes pass in decades. 13.8 billion years is longer than anything our experience has prepared us to feel. But the universe may have trillions of years ahead of it. Stars will keep forming for hundreds of billions of years. The era we live in, when the universe is bright with stars, warm with light, full of the energy of active stellar fusion, is relatively early. We are not near the end. We are, by some measures, still near the beginning. The universe is in its youth, and we happen to be here during it. The light reaching Earth from distant stars left them thousands of years ago. Some of the stars you see on a clear night no longer exist. They burned out, collapsed, exploded, transformed, long before that light completed its journey to your eyes. You are seeing a ghost, a record of something that was, not something that is. This is true of everything in the universe, at every scale. We never see anything as it is now. We always see it as it was when its light left it. The sun you see during the day is the sun as it was 8 minutes ago. The nearest star is 4 years ago. The Andromeda Galaxy is 2.5 million years ago. Now does not exist in the universe. There is only the past, arriving at different times from different distances. Distance and time are the same thing in the universe. To look far away is to look far back. To see something distant is to see something old. The further away, the further back. A telescope pointed at the deepest sky is not just a window into space, it is a window into time. A record of the universe at different ages, layered like the rings of a tree, each distance a different era. Astronomy is the only science where the past is directly visible, where you can point an instrument at the sky and see, with your own instruments, the universe as it was billions of years ago, not reconstructed, not inferred, but seen. The light is still arriving. Tonight, ancient light is arriving at this planet from every direction. From galaxies that formed when the universe was young, from stars that burned out before the Earth existed. From distances so vast, the journey took longer than anything alive on Earth has ever lived. It arrives quietly, without announcement, without knowing it has arrived at all. Only 5% of the universe is made of ordinary matter. 5%. Everything you have ever seen, every star, every planet, every ocean, every living thing, every atom of gas drifting through the space between galaxies. Everything that has ever been named, measured, touched, or understood, all of it together, is 5% of what exists. The other 95% is something else. 27% of the universe is dark matter. Not dark the way a room is dark when the lights are off. Dark in the sense of invisible matter that does not emit light, does not absorb light, does not reflect it. It passes through ordinary matter as if ordinary matter were not there. Walls, planets, people, dark matter moves through all of it without interaction, without leaving a trace. We have never seen it directly. We have never touched it. We know it exists only because of what it does, because galaxies rotate faster than they should if only visible matter existed, because light bends more than it should when passing through galaxy clusters, because the large-scale structure of the universe could not have formed as quickly as it did without something unseen providing extra gravity. Dark matter is the scaffolding the universe built itself on. Invisible, unmeasurable, directly, and absolutely essential. Right now, dark matter is passing through your body. Not occasionally, not in small amounts. Billions of particles, every second, moving through you as if you were not there. Through your skin, through your bones, through the soft tissue of everything that makes you a living thing. You do not feel it. It does not interact with the atoms of your body in any way you can detect. It simply passes silent, invisible, continuous, as it has been passing through everything since long before the Earth existed. The universe is moving through you right now. You simply cannot feel it. 68% of the universe is dark energy. The largest single component of the universe, by far the dominant thing, making up more than 2/3 of everything, is something we cannot detect, cannot measure directly, and cannot explain. Dark energy is the name we have given to whatever is causing the expansion of the universe to accelerate. It appears to be a property of empty space itself, energy that does not dilute as space expands, that grows stronger as the universe grows larger. We know it exists because of what we observe, because the universe is expanding faster than it should be if only gravity and matter were involved. Something is pushing space apart, something vast and evenly distributed and completely beyond our current ability to understand. We call it dark energy. It is a name for our ignorance as much as for the thing itself. The universe is mostly made of things we do not understand. This is not a temporary situation, a gap in knowledge that will be filled soon. These are deep, fundamental unknowns that have resisted decades of the most sophisticated scientific investigation humanity has ever undertaken. The world's largest particle accelerators, the most sensitive detectors buried deep underground, the most powerful space telescopes, none of them have yet revealed what dark matter is made of, or what dark energy actually is. 95% of the universe remains, in the most precise scientific sense, unknown. And we are built from the 5% that is known. Small islands of understanding in an ocean of mystery. Temporary arrangements of ordinary matter that somehow became curious enough to notice how much we do not know. Without dark matter, galaxies would fly apart. The stars at the edges of galaxies orbit faster than they should. Based on the visible mass alone, all the stars and gas and dust that we can see, the outer stars should be moving slowly, like the outer planets of a solar system. Instead, they move almost as fast as the inner stars. Something unseen is holding them in. Something with mass, with gravity, with the ability to keep a galaxy together against the outward forces trying to scatter it. That something is dark matter. The invisible halo surrounding every galaxy, far more massive than the visible material at the center, providing the gravitational grip that keeps the stars from flying away into the dark. The galaxies exist because of something we cannot see. We live in one of them because of something we do not understand. Dark energy is making the universe lonelier. As dark energy drives the accelerating expansion of space, distant galaxies are moving away from us faster and faster. In the very long run, trillions of years from now, most of the universe will have moved beyond the horizon of visibility. One by one, galaxy clusters will slip away, their light unable to reach us as the space between us grows too fast for even light to cross. Astronomers who exist in that distant future, if any do, will look up at a sky with far fewer galaxies. The evidence for an expanding universe, for the Big Bang, for the cosmic story we have spent centuries reconstructing much of it, will be gone, hidden beyond an ever-growing horizon. We live at a fortunate time. The universe is still visible. The evidence is still arriving. The sky is still full of ancient light to read. The universe we observe is only a fraction of what exists. Beyond the observable horizon, beyond the edge of our bubble of visibility, space almost certainly continues. Perhaps for a very long time. Perhaps forever. What lies out there follows the same physics, formed from the same Big Bang, made of the same matter, but it is forever beyond our reach. We will never see it. No telescope will ever be powerful enough. No signal will ever cross the distance. It exists, and it is as real as the galaxy you live in, but it will always remain beyond any horizon we can approach. The universe is larger than we can know, not larger than we have yet measured, larger than we can ever measure, permanently, fundamentally larger. Most of the universe's matter is invisible. The stars and galaxies we spend our lives studying, the bright things, the visible things, the things we have built entire sciences around, are a small minority. The universe is mostly dark, mostly invisible, mostly made of things that do not shine, do not emit, do not announce their presence in any way our instruments were originally designed to detect. The night sky, which feels so full of light on a clear night, is a thin scatter of bright exceptions in a universe that is almost entirely dark. What we see is the unusual part, the rare part, the part that happens to produce light. The rest, the vast majority, moves through the universe in silence, invisible, shaping everything without being seen. The ordinary matter we are made of is the universe's minority. You are built from the rarest stuff in the cosmos. The carbon, the oxygen, the iron, the hydrogen, the atoms of your body are part of the 5%, the unusual fraction, the part that shines and reacts and combines into molecules and eventually into living things. Dark matter does not become stars. Dark energy does not become planets. Only ordinary matter, the small fraction, the visible fraction, the fraction that includes you, assembles into the complexity that makes a universe interesting. You are made of the universe's most special ingredient, the part that could become curious about the rest. Galaxies are not scattered randomly across the universe. If you could map all the galaxies in the observable universe, all 2 trillion of them, you would not find them distributed evenly through space. You would find something unexpected, something that looks almost designed, almost intentional, though it emerged from nothing more than gravity and time. A web. The largest structure in the universe is called the cosmic web. Vast filaments of dark matter and gas stretching across hundreds of millions of light years, with galaxies clustered along them, like dewdrops on a thread. Where the filaments cross, enormous clusters of thousands of galaxies accumulate. Between the filaments, nothing. Great voids, hundreds of millions of light years across, nearly empty of galaxies, filled only with the thinnest traces of matter. This is the architecture of the universe at its largest scale. Not a uniform distribution, not random scattering, a network, a web built by gravity over 13 billion years, from the seeds planted by quantum fluctuations in the first fraction of a second after the Big Bang. The universe looks, at its largest scale, like something that grew. The voids between galactic filaments are almost empty. Almost, but not quite. Even in the quietest, most underpopulated regions of the universe, there are still a few stray galaxies, a few wandering stars, a thin haze of hydrogen. The universe is never truly empty. It is only more or less populated, more or less full, depending on where you look. The great voids are the loneliest places in the universe, regions where a civilization, if one existed, might look out and see almost nothing, where the nearest galaxy might be hundreds of millions of light years away, where the night sky would be darker and quieter than anything we can imagine from inside the Milky Way. The cosmic web looks like a neural network. When cosmologists map the large-scale structure of the universe, the filaments and nodes and voids, and compare it to images of neurons in the human brain, the resemblance is striking. Dense nodes connected by thread-like filaments, with vast empty spaces between them. The largest structure in the universe and the most complex structure we know of share the same shape. This is not meaningful in the way a poem is meaningful. The physics are completely different. The scales are incomprehensibly different. But it is one of those quiet coincidences the universe occasionally offers a reminder that the same mathematics can describe things at radically different scales, and that the universe has a tendency to repeat its patterns. Galaxy clusters are the largest gravitationally bound structures in the universe. Where the filaments of the cosmic web intersect, matter has accumulated over billions of years into enormous concentrations, clusters containing thousands of galaxies, vast clouds of hot gas between them, and dark matter halos holding everything together. The largest of these clusters contain more mass than the Milky Way by factors of thousands. Between the galaxies in a cluster, the hot gas glows in X-rays invisible to human eyes, but detectable by space telescopes. This gas is so hot, tens of millions of degrees, that it emits X-rays as atoms are stripped of their electrons and flung at tremendous speeds through the space between galaxies. Galaxy clusters are not collections of objects in space. They are vast, complex environments in their own right, with their own weather, their own chemistry, their own slow and violent history. The Milky Way belongs to a small group of about 50 galaxies. The local group, our galactic neighborhood, is modest by cosmic standards. The Milky Way and Andromeda are the two large spirals. Around them orbit dozens of smaller dwarf galaxies, some of them being slowly pulled apart by the gravity of their larger neighbors, their stars streaming out into tidal tails that wrap around the parent galaxy like slow, ghostly streamers. The local group is held together by mutual gravity. All 50+ galaxies are bound to each other, orbiting a common center of mass. In the very far future, most of them will merge, eventually settling into a single large galaxy. the combined remnant of everything that is currently our galactic neighborhood. The Milky Way and Andromeda are falling toward each other. Right now, the two largest galaxies in the local group are approaching, moving closer, slowly, inexorably, drawn together by the gravity of everything they contain. In about 4 billion years, they will begin to merge. It will not be a collision in the ordinary sense. Stars are too far apart to physically collide, but the shapes of both galaxies will be dramatically disrupted, arms thrown out into space, stars flung into new orbits, the two central black holes spiraling together. Over billions of years of gravitational interaction, the two spirals will settle into a single large elliptical galaxy. What we know as the Milky Way and Andromeda will one day be one thing, a larger, quieter galaxy, its spiral structure gone, drifting through the local group as a smooth cloud of stars. Beyond the local group, everything is moving away. The 50 galaxies of the local group are held together by gravity. But outside the group, beyond the boundaries of our gravitational neighborhood, the expansion of the universe takes over. Other galaxy groups, other clusters, other superclusters are all moving away, not because they are flying through space, but because the space between us and them is expanding. Everything beyond our gravitational reach is leaving, slowly, without drama, simply carried apart by the steady growth of space, the way objects placed on a rubber sheet move apart when the sheet is stretched. We are gravitationally bound to our local neighborhood. Everything else is drifting away. The universe is structured on every scale, from the smallest quantum fluctuations in the early universe to the vast filaments of the cosmic web structure appears at every level. Atoms cluster into molecules. Molecules cluster into dust and gas. Dust and gas cluster into stars. Stars cluster into galaxies. Galaxies cluster into groups. Groups cluster into superclusters. Superclusters form the filaments of the web. Structure all the way up and all the way down. The universe does not prefer randomness. Given time and gravity, it builds. It has been building for 13.8 billion years, and it is still building now. Not all galaxies look alike. The Milky Way, the spiral galaxy we live in, with its arms of stars and dust curving outward from a central bulge, is one type. But the universe makes galaxies in many shapes, many sizes, many stages of life. Some are orderly, some are chaotic, some are ancient and still, some are young and violently active. The universe has not settled on a single template for a galaxy. It makes them in all the ways gravity allows. Spiral galaxies are the ones that look like home. Arms of stars and gas curving outward from a bright center, turning slowly over hundreds of millions of years. The spiral structure is not a fixed arrangement of stars, it is a wave, a pattern moving through the galaxy, compressing gas as it passes and triggering the formation of new stars. The bright arms we see are lit by young, hot, short-lived stars born from that compression. Spiral galaxies are the most visually striking, the ones that show up in photographs, the ones that look like something from a dream. But they are not the most common. They are the interesting ones, the young ones, the ones still making stars. Elliptical galaxies are older and quieter. Smooth, featureless clouds of stars, no spiral arms, no visible structure, just an oval distribution of light fading toward the edges. Elliptical galaxies have used up most of their star-forming gas. They are not making many new stars. They are coasting on the stars they already have, slowly aging, slowly fading. The largest galaxies in the universe are ellipticals formed from the mergers of smaller galaxies over billions of years, accumulating mass without the elegant structure of a spiral. Some contain trillions of stars, and yet they are, in a certain sense, the quietest places in the cosmos, massive, ancient, and still. The largest known galaxy is 50 times the size of the Milky Way, IC 1101, located about a billion light-years from Earth, contains roughly 100 trillion stars and spans about 6 million light-years. If it replaced the Milky Way in our neighborhood, its outer edges would reach halfway to the Andromeda Galaxy. It is a giant elliptical, the product of many mergers over billions of years, each one adding more stars, more mass, more sheer size. It sits at the center of a large galaxy cluster, collecting everything that falls toward it, growing slowly larger. The Milky Way, next to IC 1101, would be invisible. Dwarf galaxies are the most common type in the universe. Small, faint, containing only a few million to a few billion stars, dwarf galaxies vastly outnumber their larger cousins. They orbit larger galaxies, interact with them, sometimes get torn apart by their gravity. Several dwarf galaxies orbit the Milky Way right now, including the large and small Magellanic Clouds, visible from the southern hemisphere as detached portions of the Milky Way. Many dwarf galaxies are rich in dark matter relative to their visible mass. Some are almost entirely dark matter, with only a thin scattering of visible stars to mark their presence. They are hard to find, but they are everywhere. Most large galaxies have a supermassive black hole at their center, including ours. At the center of the Milky Way sits Sagittarius A times a black hole, 4 million times the mass of the Sun, compressed into a region smaller than our solar system. It is quiet now, not actively feeding, not producing the powerful jets of energy that some galactic centers emit. But it is there, always there, its gravity influencing the orbits of stars in the galactic core. The relationship between a galaxy and its central black hole is one of the stranger things in cosmology. They seem to grow together. The larger the galaxy, the more massive its black hole. How they regulate each other, how the growth of one influences the other, is still being worked out. When galaxies collide, something unexpected happens. Not destruction, creation. The collision of two gas-rich galaxies compresses the gas between them, triggering enormous bursts of star formation. New stars ignite across the merging system, more stars forming in a single encounter than might otherwise form in billions of years. The collision that seems violent from outside is, from the perspective of the stars, barely anything. They pass each other with vast distances between them. But the gas clouds collide, compress, and ignite. Collisions are not endings for galaxies. They are, in many cases, beginnings. The Milky Way has already collided with other galaxies. The stellar halo surrounding our galaxy, the diffuse sphere of ancient stars orbiting far above and below the disk, contains the remnants of smaller galaxies that fell into the Milky Way billions of years ago. Their stars were pulled apart by tidal forces, scattered into long streams that still trace the paths of their former galaxies. The Milky Way is not a pristine, original spiral. It is a composite built from collisions and mergers, assembled over billions of years from the wreckage of smaller systems. Every large galaxy has a similar history. They all built themselves by consuming what fell toward them. Galaxies evolve over time. The galaxies of the early universe were smaller, more irregular, more chaotic than those we see nearby today. They were forming stars at furious rates, colliding, merging, building themselves up from fragments. The universe was more violent then, more turbulent, less settled. Today's large, elegant spirals and smooth ellipticals are the mature forms of galaxies that spent billions of years assembling themselves. They are the end products of a long, chaotic process of construction. What we see now, the well-organized, well-behaved galaxies of the present, is the universe after it has had time to calm down. Stars are born in darkness. In the cold, dense cores of giant molecular clouds, regions of gas and dust so thick that no light penetrates gravity, pulls matter slowly together. Over millions of years, a cloud core collapses. The material at the center grows denser and hotter. The pressure builds until, at a temperature of about 10 million degrees, hydrogen nuclei begin to fuse, and a star ignites, not with a visible flash, not with a sound, just a point of light, appearing where there was dark, another small sun in the making, beginning a life that will last millions or billions of years. A star spends most of its life doing one thing, fusing hydrogen into helium. This is the steady state of stellar life, the long, stable middle period between the turbulence of birth and the drama of death. For our Sun, this period lasts about 10 billion years. For the smallest, dimmest red dwarfs, it can last hundreds of billions of years. For the most massive stars, it might last only a few million. In that stable period, a star is a balance. Gravity pulling inward, fusion pushing outward. Two enormous forces, exactly matched, holding the star in equilibrium. As long as the balance holds, the star shines. The more massive a star, the shorter its life. A star 10 times the mass of the Sun burns through its fuel, not 10 times faster, but thousands of times faster. It lives brilliantly and briefly a few million years, compared to the Sun's 10 billion. The most massive stars that exist burn so intensely that they exhaust themselves in a fraction of a percent of the Sun's lifespan. They are the brightest things in the galaxy, and the most temporary. The quiet, dim red dwarfs, the most common type of star, will still be burning when the universe is 100 times older than it is now. Slowness, in stars as in other things, is its own kind of endurance. When a massive star dies, it goes out in an explosion, not a gradual fading. A supernova, one of the most violent events the universe produces. When the fuel in the core runs out, the balance fails. Gravity wins, suddenly and completely. The core collapses in a fraction of a second. The outer layers, falling inward, rebound off the collapsing core and are flung outward at a significant fraction of the speed of light. For a brief period, days to weeks, a single dying star can outshine its entire galaxy. Billions of other stars, and yet this one, dying, burns brighter than all of them combined. In the moment of a supernova, something extraordinary happens. The energy released in those final seconds is greater than the Sun will release in its entire 10 billion year life. And in that fury of energy and pressure, atomic nuclei are slammed together fast enough to build elements that no ordinary stellar fusion can produce. Iron, cobalt, nickel, and heavier elements still, all the way up to gold and uranium, forged in the seconds of a stellar death and scattered into space by the explosion. The heavy elements in the universe, in the Earth, in your body, were made in moments of stellar violence, born from endings, scattered into the galaxy to become part of new beginnings. What remains after a supernova depends on how massive the star was. For a star of moderate mass, the collapsed core becomes a neutron star, an object roughly the mass of the Sun compressed into a sphere about 20 kilometers across. The matter inside is so dense that a teaspoon would weigh billions of tons. Neutron stars spin rapidly, sometimes hundreds of times per second, sweeping beams of radiation across space with lighthouse regularity. For the most massive stars, even a neutron star cannot hold. The collapse continues past the neutron star stage into something from which nothing, not even light, can escape. A black hole forms, silently, completely. Where a star once burned, there is now simply an absence. The material from dying stars becomes the raw material for new ones. The elements scattered by a supernova, the carbon, oxygen, silicon, iron, and everything else forged in stellar interiors and stellar deaths, mix with the surrounding gas and drift through the galaxy. Over millions of years, gravity begins to pull some of this enriched material together. A new cloud forms, a new star ignites. But this star is different from the one before. It contains the heavy elements of all the stellar generations that preceded it. It is chemically richer, more capable of building complex, and the disk of material surrounding it from which planets will form contains everything needed for the chemistry of worlds. Our Sun formed from the remnants of at least 2 previous generations of stars. The solar system we live in is built from the recycled contents of stars that lived and died before ours was born. The universe does not waste anything, it only transforms it. Some stars will outlive the universe as we understand it. The smallest red dwarf stars, burning at just a fraction of the Sun's luminosity, consuming their hydrogen at an extraordinarily slow pace, have theoretical lifetimes of trillions of years. The universe is 13.8 billion years old. These stars will still be burning when it is 1 trillion years old. They will see things we cannot imagine. They will still be shining long after every other kind of star has burned out, long after galaxies have merged and dispersed, long after everything familiar about the universe has changed beyond recognition. Somewhere, right now, on a small planet orbiting a dim red star, there may be something looking up at a sky that will remain largely unchanged for longer than our species can conceive. Every atom of heavy matter in the universe was made inside a star. Not the hydrogen and helium, those came from the Big Bang, but every element above helium in the periodic table, carbon, nitrogen, oxygen, iron, gold, every element that makes rocks and planets and living things possible was made inside a star, built up through nuclear fusion in stellar interiors or forged in the violence of stellar explosions. When you hold something in your hand, a stone, a piece of metal, a living thing, you are holding material that was once inside a star, that passed through the heat of a stellar core, that survived a stellar explosion and drifted through space for millions of years before gravity gathered it into the solar system, the Earth, and eventually into whatever form it takes today. Everything solid in the universe has been through fire. A black hole is not a hole. The name is misleading. A black hole is not an absence, not an emptiness, not a gap in space. It is matter, an enormous amount of mass compressed into a very small space. So much mass, so densely packed, that the gravity it produces overwhelms everything else, including light. It is not a hole. It is the densest thing that exists. The event horizon is not a physical surface. It is a boundary, a point of no return. Cross it, and the gravity is strong enough that no velocity, no force, no amount of energy will ever bring you back. Not because there is a wall, because the geometry of space inside the event horizon points everything, every possible path, every possible direction toward the center. Inside a black hole, the future is the center. There is no direction that does not lead there, not backward, not sideways, not at any angle. Every path leads inward. Time slows near a black hole. This is not a metaphor. It is a measurable, real effect. The same effect that GPS satellites must account for to remain accurate. Near a massive object, time genuinely flows more slowly relative to time far away. The stronger the gravity, the slower the time. Near the event horizon of a large black hole, the effect becomes dramatic. An observer hovering just outside the event horizon, if such a thing were possible, would experience time at a fraction of the rate of someone far away. A year near the black hole might correspond to thousands of years elsewhere. Time is not fixed. It bends. It slows. It is shaped by the distribution of mass in the universe. The supermassive black hole at the center of the Milky Way is 4 million times the mass of the Sun. 4 million solar masses, compressed into a region smaller than the orbit of Mercury. We cannot see it directly. It is hidden behind clouds of gas and dust in the galactic center. But we can watch the stars near it, orbiting invisible mass at high speeds, tracing paths through space that reveal what must be at their center. It is called Sagittarius A. It is quiet now, not actively feeding, not producing the jets of energy that some galactic black holes emit, but it is there, always there, shaping the motions of stars in the innermost regions of the galaxy. The Milky Way has a heart of darkness. It always has. In 2019, we saw a black hole for the first time. The Event Horizon Telescope, a network of radio observatories across the Earth, operating together as a single planet-sized instrument, captured the first image of a black hole's shadow. The supermassive black hole at the center of galaxy M87, 55 million light-years away, surrounded by a glowing ring of hot gas, spiraling inward. It was not dramatic to the eye, a blurry orange ring in the darkness. But what it represented was extraordinary. The actual shadow of an event horizon. The edge of the point of no return. Something that, until that moment, had existed only in mathematics and inference. We saw it. For the first time in history, we saw it. When black holes merge, they shake the universe. Two black holes spiraling toward each other, drawing closer over millions of years, radiating gravitational waves as they lose energy. The orbits tighten, the inspiral accelerates, and then, in a final fraction of a second, they merge, converting a significant fraction of their combined mass directly into energy, released as a burst of gravitational waves. In that moment, more energy is released than by all the stars in the observable universe combined, shining simultaneously. And it is completely silent, invisible, a ripple in the fabric of space itself, expanding outward at the speed of light. Gravitational waves were first detected on Earth in 2015. LIGO, two enormous instruments in the United States, each consisting of a pair of tunnels 4 kilometers long, detected a tiny stretching and squeezing of space itself as a gravitational wave passed through the Earth. The distortion was smaller than 1,000th the diameter of a proton. It had been traveling for over 1 billion years, generated by two black holes merging somewhere in the distant universe before complex life existed on Earth. It crossed 1 billion light-years of space, arrived at our planet, passed through LIGO, and was recorded. Einstein predicted gravitational waves a century before we detected them. The universe confirmed his mathematics with a signal from 1 billion years ago. Black holes may eventually evaporate. Stephen Hawking predicted that black holes slowly lose mass over time, that quantum effects at the event horizon cause a tiny trickle of energy to escape, taking mass with it. For a black hole the size of the Sun, this process would take longer than the current age of the universe, trillions of times over. But given enough time, given the unimaginably long future that may await the universe, even black holes do not last forever. They shrink, they fade, they evaporate in a final burst of radiation, leaving nothing behind. The most enduring objects in the universe are not permanent. They are only patient. Black holes are not the monsters we imagine. They do not move through space, devouring everything in their path. They are gravity, the same force that holds you to the Earth, that holds the Earth in orbit, that holds the galaxy together. A black hole, the mass of the Sun, would hold the solar system in the same orbits as the Sun itself. It would not pull anything in that is not already falling toward it. The difference is the scale, the density, the inability of anything, even light, to escape once it gets close enough. But from a safe distance, a black hole is simply a mass. Invisible, yes. Strange, certainly. But not hunting, not reaching, not pulling at things that are not already its to hold. The universe is 13.8 billion years old. If you wrote that number out in seconds, it would fill a page. If you tried to count to it at one number per second without stopping, it would take 437 years. The human mind is not equipped to feel this number, only to hold it at a distance. As a fact, as a word, as something that has no meaningful equivalent in ordinary experience. 13.8 billion years. The whole of human civilization occupies the last 10 seconds of that timeline. Everything you have ever learned about history, every empire, every discovery, every war, and every peace fits into the final moments. Everything we see is the past. Light takes time to travel. The sun you see is 8 minutes old. The nearest star is 4 years old. The Andromeda Galaxy is 2.5 million years old. The most distant galaxies we observe are 13 billion years old. The universe as it was when it was young, before the Milky Way had taken its shape, before the Earth existed. You are surrounded, at every moment, by the past. The universe, as it is right now, as it is in this moment, everywhere simultaneously, is something you will never see. You only see what was, arriving at the speed of light, from many different distances, and therefore many different times. The sky is a time machine. Every direction you look is a different era. Some stars you see no longer exist. The light from a star that burned out 1,000 years ago may still be traveling toward Earth. It may still be arriving tonight. In a sky of thousands of visible stars, some percentage of them, we do not know exactly how many, are already gone, collapsed, exploded, faded, ended long ago. But their light continues. It left when they were still burning, and it has been traveling ever since, completing a journey its source can no longer witness, arriving at eyes that the star never knew would exist. The night sky contains ghosts. Light from things that no longer are, still traveling, still arriving, still telling their story. Time is not the same everywhere. This is one of the discoveries of the 20th century that most quietly reshapes how the universe is understood. Time does not flow at a fixed rate. It flows faster in weak gravity, slower in strong gravity. It flows faster for something moving slowly, slower for something moving fast. The GPS satellites orbiting Earth must account for this. Time runs slightly faster at their altitude, where gravity is weaker than at the surface. If that difference were not corrected for, GPS positions would drift by kilometers per day. Time is not a backdrop. It is part of the fabric, and the fabric bends. In the far future, the last stars will go out, not all at once, not in a single moment of darkness. One by one, over hundreds of billions of years, stars will exhaust their fuel and fade. The blue giants first, the most massive, the most brilliant, the most short-lived. Then the yellow stars like our Sunday. Then the red dwarfs burning dimly for trillions of years before finally cooling. And then nothing new forming. The gas that once collapsed into stars gradually locked up, used, no longer available for new stellar births. The galaxy growing quieter, the light slowly fading, the universe entering an era of darkness it has never known, a permanent night, unbroken by starlight, populated only by remnants. After the stars, black holes remain. In the era after the last star burns out, the universe will be populated primarily by cold remnants, white dwarfs cooling over billions of years, neutron stars spinning in silence, and black holes. The supermassive black holes at the centers of galaxies and the smaller black holes scattered throughout these will be the last large structures in the universe. They will evaporate, eventually, over timescales so long they have no meaning in any human frame of reference. But they will fade, one by one, until the universe is left with nothing but a thin fog of particles and radiation, spreading through an expanding space, cooling toward absolute zero. The fate of the universe is still unknown. What happens in the very far future depends on what dark energy does. If dark energy remains constant, as current observations suggest, the universe will expand forever, growing emptier and colder until it reaches something called heat death, maximum entropy, the quietest possible state. If dark energy grows stronger over time, it may eventually tear apart not just galaxies, but solar systems, planets, atoms themselves, in an event called the Big Rip, where the expansion overwhelms every force that holds matter together. If dark energy reverses, the universe might slow, stop, and collapse. A big crunch, the reversal of the Big Bang, everything falling back together. We do not know which of these futures is ours. The answer depends on the nature of something we do not understand. There is no universal now. This is one of the stranger implications of Einstein's relativity. Two observers moving at different speeds experience time at different rates. Two events that appear simultaneous to one observer may appear to happen in a different order to another. There is no single, universal moment of now that applies across the entire universe. The universe does not have a clock. It has local times, relative times, times that depend on where you are and how fast you are moving and how strong the gravity is around you. Right now, on the other side of the galaxy, time is ticking at a slightly different rate than it is in this room. The universe does not synchronize itself. It simply moves, each part at its own pace, following the same laws but arriving at different moments. The universe is patient in a way nothing else is. Stars burn for billions of years. Galaxies form over billions of years. The cosmic web assembled over the entire lifetime of the universe so far, and it is still assembling. The processes that shaped everything, gravity pulling matter together, stars forging elements, supernovae scattering them, all of these operate on timescales that make human history invisible. We find this hard to feel. We live in decades. We think in years. The universe thinks in epochs. But lying here tonight, in the quiet dark, there is something almost peaceful in the thought of it. The universe does not hurry. It has not hurried in 13.8 billion years. It is in no rush tonight. Life required the universe to grow up first. The first stars were made of hydrogen and helium only, none of the heavier elements that carbon-based life requires. For life like us to be possible, generations of stars had to live and die, forging the heavier elements and scattering them through the galaxy. This took billions of years. The universe had to be at least 9 or 10 billion years old before the conditions for life as we know it could arise. We formed just in time, born into a universe mature enough to contain us, but not so old that the stars are fading. We could not have existed any earlier. The Earth sits in a rare position, not just the right distance from the Sun, though that matters enormously, but also in the right part of the galaxy, far enough from the crowded, radiation-intense galactic center, far enough from the spiral arms where supernovae are common. In a quiet region where the radiation environment has been stable enough for long enough for life to develop without constant disruption. The habitable zone is not just a distance from a star. It is a position within a galaxy, in an era of cosmic history, around a star of the right type and age. Earth checks a remarkable number of boxes. The silence of the universe may be its own message. For decades, we have searched for signals of intelligent life beyond Earth. Radio signals, optical signals, any evidence of technology, of intentionality, of a civilization transmitting into space. And we have found nothing. The universe is enormous. The conditions for life may be relatively common. And yet, silence. This is called the Fermi paradox. The question it raises has no agreed answer. Perhaps intelligent life is rarer than we think. Perhaps it arises and then disappears before it can send signals very far. Perhaps the signals are there and we are not yet equipped to receive them. Perhaps we are, against all probability, alone. We do not know. The silence continues. We are made from the oldest material in the universe. The hydrogen in your body was made in the first 3 minutes after the Big Bang, nearly 14 billion years old. It has drifted through interstellar space, been incorporated into stars, been part of other solar systems, been part of the Earth's oceans, been part of living things, and now it is here, in you, in the water of your cells, in the most intimate material of your biology. You are carrying something almost as old as everything. The carbon in your body came from a star that died before the sun was born. Carbon is the backbone of biology, the atom around which all the complex chemistry of life is organized. It was not present in the early universe. It was made inside stars through a process called the triple alpha reaction 3 helium nuclei, fusing into one carbon nucleus under the conditions found in the cores of aging stars. When those stars died, some quietly, some violently, they released that carbon into space. It drifted, it cooled, it became part of molecular clouds, part of new solar systems, part of the chemistry of young planets, and eventually, after billions of years of cosmic travel, it became part of you. Every breath connects you to the history of the cosmos. The oxygen entering your lungs was released by photosynthesis by billions of years of living things, using sunlight to split water molecules and release oxygen into the atmosphere. The nitrogen mixed with it was cycled through the biosphere, through the atmosphere, through the chemistry of stars and nebulae across billions of years. The air in this room has a history as long as the universe itself. Its atoms have been through stars, through space, through oceans, through living things, through the entire length of cosmic time. And now they are here, moving in and out of your lungs as you rest. Breathing is a transaction with the universe. You have been making it your entire life. The universe produce something that can be curious about the universe. Somewhere in the long story of expanding space and forming galaxies and igniting stars and forging elements and scattering them and building planets and warming oceans, somewhere in all of that, something happened that had not happened before. Matter became curious about itself. Not everywhere, not often as far as we know, but here, on this small planet, in this thin layer of biology covering its surface, the universe arranged itself into forms that ask questions, that look up at the sky and wonder, that try to understand where they came from and where they are going. This may be the most extraordinary thing the universe has ever done. More extraordinary than any black hole, any supernova, any scale of structure. That 14 billion years of physics should eventually produce something that looks back at the physics and wonders about it. We do not know if we are alone. This may be the single most important unknown in all of science. The universe is vast. The conditions for life may be widespread, and yet we have found no evidence that life exists anywhere other than Earth. No confirmed signal. No confirmed detection, no confirmed anything. We may be alone in the observable universe, the only living things in 93 billion light-years of space, the only minds in everything we can see, or there may be others, perhaps many others, and we simply have not found each other yet in a universe too large and too old for easy communication. Both possibilities are extraordinary. Both change something fundamental about what it means to be alive. The universe is indifferent to us, and that is not a sad thing. The universe did not make us for a purpose. It did not design the conditions for life. It did not intend for stars to forge the elements or supernovae to scatter them, or planets to form inhabitable zones. These things happened because of physics, gravity, nuclear forces, chemistry operating without intention, without goal, without awareness. And yet, here we are, the accidental product of 14 billion years of physics arranged into something that can feel wonder, that can be moved by the size of the universe, that can lie in the dark and feel perhaps something like awe. The universe does not know we exist. And we know the universe exists. That asymmetry is one of the most remarkable things about being alive. You have been part of the universe for nearly 14 billion years. Not as you, not as this body, this mind, this particular night, but the matter you are made of has been here since almost the beginning. It passed through the first stars. It drifted through the cosmic dark ages. It was gathered by gravity into the solar system, into the Earth, into the oceans, into the long chemistry of life, and eventually, through a process no one fully understands, it became something that breathes and thinks and wonders. The atoms in your body are nearly as old as everything. You are built from the universe's rarest ingredient. Ordinary matter, the atoms, the elements, the stuff that shines and reacts and combines into molecules, is only 5% of what exists. Dark matter does not become stars. Dark energy does not become planets. Only ordinary matter assembles into the complexity that makes a universe interesting. You are made of the part that could become complex, the part that could become alive, the part that could, after 14 billion years of cosmic history, become curious. The iron in your blood was forged in a star that died before the sun was born. Iron, the element at the heart of hemoglobin, the thing that makes blood red, the thing that carries oxygen through your body, was made in the core of a massive star, built up through layers of fusion until it accumulated at the center and triggered the star's collapse, released in the explosion that followed, drifted through space, became part of the cloud that formed the solar system. You carry a star's death inside you. Every heartbeat moves it through your body. Every breath is sustained by it. The hydrogen in your cells has existed since the first 3 minutes, nearly 14 billion years old. It has never been created again. Hydrogen from the Big Bang is the same hydrogen that has been cycling through the universe ever since, through stars and space and oceans and living things, through every form matter can take, across the entire history of the cosmos. And tonight it is here, in the water of your cells, in the most intimate chemistry of your body, the oldest thing in the universe, doing the quiet work of keeping you alive as you rest. You are not separate from the universe. You are made of it. You are an expression of it, a temporary arrangement of its oldest material, animated by processes that have been running since before the Earth existed, capable of something no other arrangement of matter we know of can do. You can know the universe. You can wonder about it. You can lie still in the dark and feel, somewhere beneath the thinking, something that has no good name, a kind of recognition, perhaps, a sense of being part of something enormous. The universe is not out there, separate from you. It is here. It has always been here. You have never been anywhere else. Every question you have ever asked about where you came from has the same answer: the universe. Unfolding over 13.8 billion years. Every person who has ever looked up at the night sky and wondered, every civilization that has built a mythology around the stars, every scientist who has pointed an instrument at the sky and tried to understand all of them asking the same question in different languages, in different centuries, with different tools. Where did we come from? And the universe answers, as it always has, in the only language it has, in the light still arriving from distant stars, in the ancient glow filling the sky in every direction, in the iron in your blood, and the hydrogen in your cells, and the carbon that holds your biology together. You came from here. You have always been here. You are the universe, asking about itself. The universe will continue long after this night, long after everything alive tonight is gone, long after the sun has expanded and the earth has been swallowed or scorched, long after the Milky Way and Andromeda have merged into something new, long after the last star burns out and the last black hole evaporates and the universe reaches the quiet, cold stillness of its final state. It will continue, patient, vast, indifferent to any particular arrangement of matter, to any specific moment, to any single night, on any single planet. It continues now. It will continue when you wake. It will continue forever, in whatever form forever takes in a universe like this one. And right now, in this moment, the universe is here, in this room, in your body, in the iron in your blood, and the carbon in your cells, and the hydrogen that has been part of everything since the first minutes of everything, in the ancient light passing through you from every direction, in the gravity holding you to this planet, which is held by this star, which moves through this galaxy, which drifts through the cosmic web, which is the universe arranging itself as it has always arranged itself, matter and energy and time, following the same laws they have always followed, producing something new in every moment. You are not watching the universe tonight. You are the universe, resting. The night sky you cannot see right now is unchanged. The stars are there. The galaxies are there. The ancient light is traveling, as it always travels, in every direction, across distances that have no equivalent in ordinary experience. The universe is doing what it has always done, expanding, building, slowly becoming whatever it will one day be. And here, in this room, in this body, on this small, warm planet, one small part of the universe is lying still, breathing slowly, thoughts softening, the day dissolving. Rest now. The universe will still be there in the morning. It has been there for 13.8 billion years. It can wait a little longer. Somewhere, right now, a star is being born. In a cold, dark cloud of gas and dust somewhere in the Milky Way, gravity is pulling matter together. Slowly, over millions of years, it will compress into something hot enough to ignite. Another star will join the galaxy's inventory, another point of light in the long dark, another furnace building elements that will one day become something. You will never see it. It will ignite long after everyone alive tonight is gone. But it is happening now. The universe is still making things, still building, still producing new light from old darkness. And somewhere, a star is dying. A massive star somewhere in the galaxy is approaching the end of its fuel. Its core is building toward the threshold where fusion can no longer hold gravity back. When it crosses that threshold in 1,000 years, in 1,000,000 years, in the next moment, it will collapse and explode. It will briefly outshine its entire galaxy. It will scatter into space the heavy elements it spent its life assembling. It will seed the galaxy with the material for new worlds, endings and beginnings happening simultaneously. In a universe too large for any single vantage point to see more than a small fraction of, somewhere a galaxy is colliding with another galaxy. Billions of light years away, two spirals are passing through each other in slow motion, their stars barely interacting, but their gas clouds compressing, new stars igniting across the merging system. In 100 million years, what was two separate galaxies will be one, its shape forever altered by the encounter. New stars will burn in regions that were empty before. Something new will exist that did not exist before. The universe is never still. Even in the deepest silence, even in the cold, empty spaces between galaxies, something is always happening. Something is always changing. Something is always beginning. And here, tonight, on this small planet, in a quiet arm of an ordinary galaxy, you are resting. The iron in your blood was forged in a dying star. The carbon in your body was made in a stellar furnace that burned out before the sun was born. The hydrogen in your cells has been part of the universe since the first 3 minutes of everything. You are carrying the history of the cosmos in your body, the oldest material there is, assembled into something temporary and warm and alive. Tonight, that assembly is lying still, breathing slowly, letting the day go. The universe does not know you are here. It does not know this planet exists. It does not know any planet exists. It has no knowledge, no awareness, no preference. It simply is vast, expanding, following its own laws, producing stars and galaxies and black holes and empty space in the same indifferent process that has been running since the beginning. And yet you know the universe exists. You have spent tonight traveling through it from the first moment of the Big Bang to the last star burning out, from the nearest star to the most distant galaxy, from the dark matter passing through your body to the ancient light surrounding you in every direction. You know the universe. The universe does not know you. That asymmetry, that strange, remarkable imbalance may be the most extraordinary thing about being alive. Let it settle now. Not as information, not as facts to be remembered and retrieved, just as a feeling, the feeling of being small in something enormous, and finding that smallness not frightening but peaceful. The feeling of being made of ancient material, of carrying the history of stars in your body, of being a temporary arrangement of something that has always existed and always will. You are not separate from what you heard tonight. You are made of it. The universe is expanding right now. Distant galaxies are moving apart. Space is growing. Ancient light is traveling. Stars are being born and dying. Black holes are slowly, imperceptibly losing mass. The cosmic web is continuing its long, slow assembly. Dark energy is doing whatever dark energy does, in ways we do not yet fully understand. All of this, right now, simultaneously, while you lie still. The universe does not pause for sleep. It continues, as it always continues, in every direction, at every scale, following the same laws it has followed since the first moment. And you are part of it. A small, temporary, breathing part of something 13.8 billion years old and expanding in every direction. Close your eyes. The universe will be there when you open them. It has been there for 13.8 billion years. It will be there in the morning. It will be there long after this night, long after this life, long after everything that now exists has transformed into something else. You are inside it. You are made of it. And tonight, you are resting. Let the breathing slow. Let the body grow heavy. Let the thoughts dissolve into something quieter and deeper than words. The universe is vast, and you are here, warm, inside it. Good night.